right, in this video, I'm going to teach you guys how to find the end behavior of a quadratic equation. All right, so given the equation as a graph, and remember, even if it's not given to you as a graph, you can always type the equation in decimals to get your graph. You can identify the end behavior by basically focusing on the arrows, the ends of the actual parabola. So as you can see, the first statement says, as x, and I know you see that arrow, that means approaches. As x approaches negative infinity. Pause. Let's talk about what that means. X approaching negative infinity. Well, here's my x-axis. I'm basically looking at all the numbers on the x-axis. If they're saying negative infinity, I'm basically talking about these negative numbers on the left side. And of course, they're going to keep going and going way past -6, all the way to negative infinity. So on this side, do I see an arrow on that parabola? I sure do. It's right here. And it's facing up. So if it's facing up, that means it's going all the way up to positive infinity. So in that first statement where it says, as x approaches negative infinity, my y approaches positive infinity. In the second statement, it says, as x approaches positive infinity. Now, let's talk about that. If we're talking about positive infinity, that means we're looking at these numbers right here on this side that's going to keep going all the way to positive infinity. Do I see an arrow? I surely do, and it's pointing up. So that means it's also going to positive infinity. So basically, when you have a parabola and both of your arrows are pointing up, your end behavior should end with positive infinity on both flanks. But when it's pointing down, take a wild guess what they should end with. Yep, you are correct. Negative infinity, because that means they're going to keep going down, 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 and never stop. And that's it.